Well, hello. All right, let's get started. So we're gonna do the group work video. Let's start with number one. Number one gives us this huge f of x function, and we're tasked to find all these pieces, continuous or limit from the left, limit from the right, the limit altogether, and then if they're continuous. All right, let's start. X is equal to 9. Okay, so for x is equal to 9, it's going to be right here. And we see, let me just do it like this, I guess. And we see here that that value is probably in the middle. Let's just go ahead and assume 3.5. The limit as it comes from the left is, so as we see here, technically 3.5. The limit as it comes from the right does not exist because there's not a right of this value. Um, the limit altogether then does not exist. And then because we see that even though that exists, this limit does not exist, it is not continuous. All right. Next we have x is equal to 4. Okay, for this one, it's pretty safe to say that this value does not exist. The limit, though, as x goes to the left of 4, for this one, this technically doesn't exist either, even though we see that it exists to 1, 2, 3. There is this space where this function doesn't seem to go all together, so that's a dot, right? Um, so it just does not exist from 3 to 4, so therefore the limit as it comes from the left does not exist. However, from the right, that's an arrow. So that's going to imply visually that it's going to keep going that way, and it doesn't actually seem to stop. So that means that the limit as x goes to 4 from the right is technically infinity. However, the limit altogether as x goes to 4 does not exist because of it doesn't exist from the left, and then it's definitely not continuous for a lot of reasons, actually. All right. Next, we're going to do x is equal to 3. Okay, so from here, x is equal to 3. We see that that value is just going to be 9. As it comes from the left, that value is 9. As it comes from the right, it doesn't exist. Does not exist. So limit altogether does not exist and is not continuous at that point. Okay. Right. Next, x is 0. So that's just going to be the y-axis altogether. We see that here that that value is going to be 6. As it comes from the left, it exists. As it comes from the right, it is 6. And then altogether, they do match, so we're allowed to say altogether the limit is 6. And then it is continuous at this point, so yes. Okay. All right. Next one. X is equal to -3. So -3 is going to be right here. Okay, well, it's a whole, but it does reside here. That f of 3, because the closed circle is going to be 6. I'm sorry, not 6, -6, silly. And then as it comes from the left, it's going to be 5. As it comes from the right, although it does have that weird little dip, it's still going to be 5. They do match. The limit altogether is 5, but these guys, or I'm sorry, these guys over here do not equal. So that is it. They are not continuous for that one. Okay. All right. Last one. I just realized. Okay. I was doing a little bit pattern. I'm going to keep it. And we have x is equal to -5. So we see that here it does exist, and it's going to be -2. As it comes from -5 from the left, it's going to be -2. However, from the right, we have to follow this line, and that line suggests that's going to be 7. They do not equal, they do not exist, and because these two guys, well, this doesn't exist, period, but either way, they don't match, so they just not exist. All right. Let's go to number two. Number two, is the function continuous at x equal to 1? If it's not, label the discontinuity. Okay, so from here, we have, here, let me use this one. From here, we're checking x equal to 1. Technically speaking, we have to check both sides of the limit. Let's do that first part first, where you check if f of 1 exists, which you follow the rules, you would have to do x squared, so 1 squared plus 1, 1 plus 1, 2. And then for the second one over here, you check the limit, but it's piecewise, so you have to check both the limit as x goes from, or x goes to, not from, 1 from the left of f of x, and then as x goes to 1 from the right of f of x. From the left, we see that we would follow with this function, so this is the limit as x goes to 1 from the left of x plus 2. And then this one, because it's coming from the right, we would follow this function, x squared plus 1. We see that here, just using classic substitution ideas, this is going to be 3. And this, we can't really did it, it's going to be 2. And although, oh wait, I forgot a step. And we could say for the final limit, as x goes to 1 of this function, it does not exist. So we can't check for step 3 because this limit does not exist. Okay. But what kind of discontinuity is it? Well, technically speaking, right, it's not a whole because we see that there isn't a limit here and it's not able to match, but we can see that there's going to be a jump since the left-hand side of the limit and the right-hand side of the limit is different. So therefore, it's a jump. A jump. I'm spelling it wrong. A jump discontinuity. Okay, over here is a continuous at x equal 3 if it's not labeled discontinuity. Okay, well, you can check f of 3, and that's going to be 9 minus 9 over 3 minus 3. That's safe to say it's 0 over 0, which already proves discontinuity. Let's practice going over everything now. If I'm doing the limit of this, the limit as x goes to 3, I would look at that fraction and I would hopefully either see difference of squares or use this to factor out a polynomial x minus 3. Actually, let's use the dividing it, or yeah, let's divide it by a polynomial that has a root of 3, since we saw that 3 gives you 0 for that top entry. So that's going to be x minus 3, x squared plus 0, x minus 9, x squared minus 3x. Subtract that, 3x, negative 9. What do we need to make x to make this 3x appear? We need to multiply by 3. So 3x, and then negative 3 times 3 is negative 9. So that will perfectly divide out. And we can rewrite this as a limit of x minus 3 times x plus 3 on the top, and then x minus 3 on the bottom. Those cancels out, and we're left with x plus 3. Using substitution ideas, we see that the limit is 6 in that case. And then 7, and then 3, we cannot check. We can't check, and that f of 3 does not exist. So because that does not exist, we have it to where we need to figure out what kind of discontinuity it is. We can erase C from here that was going to be discontinuous either way, but we need to label the specific discontinuity. We saw that this does not exist and they don't match, so therefore it is a whole or a what do we call it? We call it something else. Let me look through my notes real quick. I'm used to calling it a whole, but I believe there's versions of it in your book where they call it the thing that I wrote it as. So they called it a removable discontinuity. Ah, all right. Let me know if you guys have any other questions about this. Right now I'm probably gonna film the I'm probably gonna film your guys' review, so please keep that in mind. For the review, you could do it before you watch the video, but you technically don't have to. I'm not gonna expect you to, but um, I'll let you guys decide if you want to do it or not, or at least give it a healthy look. Print it out, give it a healthy look, and then see what you all think. All right, that's gonna end the video. I'll see you guys on the next one. Bye bye.